Hello guys, welcome to my channel Learning with Saritha. It's my pleasure in presenting a video on the topic electric flux through an arbitrary area placed in non-uniform electric field. Electric flux is the property of an electric field, that is, when we place an area element in uniform electric field, the number of lines crossing the area element gives the electric flux. And to the electric flux depends on two factors, that is the magnitude of the electric field and to the area element that is placed in the electric field. And the arbitrary area is an irregularly shaped area element, that is the area element may be of bend or curved, that is it's not of flat surface, and we consider it is as arbitrary area. And for non-uniform electric field, we know that the electric field vectors have different magnitude and different directions in different points of the region of electric field. So whenever we draw a non-uniform electric field, on one side we give the intensity of the electric field to be more, that is we draw lines like closer lines, and as the distance increases we draw farther apart, showing that the intensity is less, and this picture denotes the non-uniform electric field. Now in this topic we have to place an arbitrary area element in non-uniform electric field and find the electric flux of that area element. We consider an non-uniform electric field and an arbitrary area element, that is an irregular shaped area element, not a flat surface, is placed perpendicular to the field lines. Here the field lines are stronger and on the other side the field lines are too weak. And what's the task of our topic? We have to find the electric flux, that is the number of electric field lines passing through this irregularly shaped area element which is placed in a non-uniform electric field. If any regular shaped area element is placed in uniform electric field, the formula for electric flux which we use is phi E is equal to E vector dot A vector. That is, the electric flux is a scalar which is obtained by taking the dot product of the electric field E vector and A vector. And here the dot product of two vectors which we are taking is giving the answer as a scalar. And it is an important and interesting property of vectors, that is, when we take the dot product of two vectors, the answer which we get is a scalar, that is it is giving just the number and no direction, that is it does not possess the property of the vectors. And to the dot product of two vectors is equal to the modulus of the two vectors times the cosine of the angle between them. If the vectors are A vector and B vector, the result is A vector mod B vector mod cos theta. Here in our topic we take the angle between the electric field E vector and normal area vector, and so the result will be E vector mod A vector mod cos theta. That is, dot product of E vector and A vector is equal to E vector mod A vector mod cos theta. Now we are going to find the electric flux for irregular area element in non-uniform electric field. How we are going to find? The only way is to split or divide the irregular area element into smaller area elements. That is how we are going to find the electric flux for irregular area element in non-uniform field. We are going to split the irregular area element in non-uniform electric field to n number of smaller area elements. That is, the smaller area elements are considered to be regular shaped area elements, and the electric field passing through those smaller regular shaped area elements are of uniform field. Here you see the irregular shaped area element which is placed in non-uniform electric field, I have split the area elements as del A1, del A2, del A3 and so on up to del AI. And the electric field lines which are linked with this area elements are E1 vector is the field passing through the element del A1 and E2 vector is the field passing through the smaller area element A2. E3 vector is the field lines passing through the area element del A3 and so on up to EI vector is the electric field lines passing through the smaller area element AI. And here del A1 vector, del A2 vector, del A3 vector and so on up to del AI vector or the normal area vectors. That is the normals drawn to each smaller regular shaped area elements. Now what will be the angle between the area vector A vector and the electric field E vector? I have chosen one smaller area element and this A vector indicates the normal to the area element, that is it is at an angle of 90 degree from the surface of the area element. Here this indicates the non-uniform electric field passing through the area element. So I have drawn a tangent to this field line and at the point of intersection of the E vector and A vector I give the angle theta, and this angle theta changes for every smaller area element. Since it is an irregular shaped area element, theta will be changing. Okay, now the electric flux for all the smaller area elements must be calculated. So the flux phi E will be equal to E1 vector dot del A1 vector plus E2 vector dot del A2 vector plus E3 vector dot del A3 vector plus and so on up to En vector dot del An vector. And so the total will be written by using summation. Flux phi E is equal to summation I is equal to 1 to n Ei vector dot del Ai vector. Here you see that the number of elements which we are dividing may reach infinity because it is an irregular shaped area element. So the number of area elements n approaches infinity, and this infinitesimal area element which we divide, we are splitting the area element now, so that each element sometimes it even approaches zero value, not exactly zero value but the value just before the zero value. So del Ai approaches 0. In this state, when del Ai approach 0 and n approach infinity, we can remove the summation and introduce the integration. So flux phi E is given by integral E vector dot dA vector. The total electric flux for an arbitrary area placed in non-uniform electric field is given by phi E is equal to integral E vector dot dA vector. And therefore the electric flux for a given surface depends on two factors. First one is the electric field pattern on the surface area, that is how far the field lines are uniform which is passing through the area element, and to the orientation of the surface with respect to the electric field, that is how far the position of the area element, whether it is placed perpendicular or parallel or somewhat inclined to the electric field lines. Guys, you see here I have chosen an irregular shaped area element and non-uniform electric field lines are passing through this irregular shaped area element, and I have split this into regular shaped area elements. Here see, these are the regular shaped area elements and the area vectors or pointing outwards, that is the area vectors make an angle of 90 degree from the surface of the area element. Here you see, here there is an angle theta between the E vector and the A vector, and here the angles theta is 0 because the electric field E vector and the A vector are both parallel to each other, and here the theta is somewhat larger value between the electric field line and the A vector. So to find the overall electric flux, we have to divide this whole area element into smaller area elements, and we have to find the integration of all the flux values. The electric flux through an arbitrary area element placed in non-uniform electric field is given by the expression phi E is equal to integral E vector dot dA vector. Okay guys, I hope that you all clearly understood the concept of the electric flux through an arbitrary area in a non-uniform electric field. After watching the video, you click the like button, share my video and subscribe to my channel and travel with me to get full mark easily. Thank you.